Welcome to Brain Vision.
Question we will be learning about some basic concepts of the chemical reaction. So in the given question we have to determine the mole fraction of carbon monoxide in the products and the heat transfer from the combustion chamber during the process. So first of all we will write the general equation for the given situation case, right? So in this case the reaction would be the balanced equation would be C6H6 plus 7.5 O2 plus 3.76 nitrogen. This will give 6 CO2 plus 3 H2O plus 28.5 nitrogen. Accounting for the lack of air and the incomplete combustion, the reaction would be modified and the reaction would become C6H6 plus 0.95 into 7.5 oxygen plus 3.76 nitrogen ECO2 plus 6 minus ECO plus 3 H2O plus 28.5, sorry, plus F nitrogen, right? The analysis of the reaction will give the values of E and F. So E would be equal to 5.25 and F is equal to 26.79. Now we can determine the mole fraction of the carbon monoxide. So the mole fraction of carbon monoxide would be equal to the number of moles divided by the total number of moles. 0.75 divided by 5.25 plus 0.75 plus 3 plus 26.79, right? So when we solve this, we will get the mole fraction of carbon monoxide and that would be equal to 0.021. Now we can easily determine the heat transfer. To determine the heat transfer, we can use the table A26 for the enthalpies of formation and we can use the table A18 to A23 for the molar enthalpies, right? So with these two tables, we can determine the heat transfer from the formula, that is the total heat transfer for the reactant minus for the products. So when we solve this, we get the value as 2113 megajoule per kilomole, right?